Alrighty, it's time for the Desk of Ladyada.
Hey everybody, welcome to Desk of Ladyada. It's me, Ladyada, back at my desk, also trying to get back on, a weekly schedule. I think like we've slowly been shifting Desk of Ladyada back to this sort of Sunday evening, afternoonish time. We're hunkered down, ready for a big snowstorm, but that just means we can do more electronics.
And I'm feeding a baby off screen.
Yeah, the baby was napping, and then of course once I started talking,
when she heard Desk of Ladyada, she's like,
I love that show.
Is it like milk for me?
Yeah.
Okay. So
let's go to my computer, and then you can just pay attention to the baby. You don't.
Yeah, I will.
I don't need you anymore.
And as you get going, just a reminder: we have fantastic articles about what's going on in the world. If you want to know what this transition is from the way we used to use computers to the way that we're going to continue to use computers and the things that are changing, check our site. It looks like everybody's starting to come around, that something's happening, and we're going to keep our values. We're going to do open source, and we hope to see you on the other side because we're going to do good.
Yeah.
But it's not going to be what everyone's expecting, and it's not going to be what maybe everyone wants, but it's going to be what our customers and our community wants. So
as Phil always likes to say, you get what you want, just not the way you wanted it.
Sometimes you get what you want, but you most often don't get it the way you wanted it.
Yeah, check out like the blog. I've been previewing and doing some very light edits on PT's articles. They're awesome. I like that he's really like churning out a lot of these really good book reports.
We got an email today.
Yeah.
And I'm going to try to do a post. I did a book on Lord of Lights, book from the 60s.
Delancey.
And someone said, hey, I was at MIT when we were making the first operating system, and we named stuff after that book. It is so cool that you decided to do that, Phil.
Yeah. This is why we publish. Okay, cool. So let's get into you. Maybe asleep again. Who knows?
Yeah, she's sleeping, sort of.
We love her. She's had her 3-month appointment.
Yeah, she's doing good.
Everything's great. She's right on track. All the development. I'm still coughing a little bit. Okay, so we are doing really good. We got a lot of breakouts on the way. It is Lunar New Year, which means our PCBs are delayed because everyone is on holiday. They deserve it. Take a break. So we will get a lot of those PCBs that we chatted about and designed over the last couple of weeks, probably another 2 weeks. That's cool. Also, once Lunar New Year is over, we'll be able to order those GigaChad and the, what do we end up calling this again? TD-Chad? Mini-Chad boards. We'll get those ordered as well. It's like 4-layer boards with Enig red. You need to have the factory back online. So looking at, I've been like getting all this stuff off my desk thanks to OpenClaw, because having something that can just churn through the data sheet and like run all the work and then do all the tests has been great. One of the things that I started like about a year ago is I was going to write a library for the uBlox chipset. And so I think I chatted about this, like I said, about maybe about a year ago when I was doing it, is the data sheet is 475 pages long. And it's just like, there's a massive number of commands. Each command has like different bits and responses. And it's like, there's like easily 50, 80 different messages you have to parse. I started parsing them. And I was doing it with Sonnet, and I was like making good progress. But even with Sonnet, I was like dying because it was like there's just so much to do. But with OpenClaw, I basically set it on a path. I said, do a design document, and use the new Sonnet 4.6 as an assistant because it has that 1 megatoken context that can like help you digest that whole data sheet and then maybe like spit out the subsections. This is the implementation plan that Opus came up with. And, it didn't actually update this because it didn't end up implementing everything. So what I did is I actually set it again to just like do self-tests, like run on its own, test yourself, run overnight, and let me know when you're done. It's about like maybe 50, 60 bucks in tokens. And all the hardware tests go here in message tests, and it categorized them by like numbered them so I could like go through in order and I wouldn't get confused about like which is the most important to do first. So this is like the first test that it wrote itself. And again, like I, kind of let it do its own thing on its own. I did once in a while ask you questions, I answered them, but for the most part, like really Opus and Sonnet and Codex did all the work for me. One thing that was interesting is Claude through Opus through OpenClaw said, hey, the way you did this when you wrote the library is you received the message into a buffer, and then you started like reading each byte, and you kind of sectioned off each byte and like assigned it to a different variable, and that's how you would parse each message. And it was like, yo, we're not going to be able to do that. We're going to not run out of memory, but it's just that the size is going to balloon. The more efficient way to do this is to mem copy the received data buffer after the CRC onto a struct. And I was like thinking like, oh yeah, you're right. Because if you look at like, let me see if like, is it nav, pvt, nav. I don't know if it's the message is here. Let me see if I can find. Oh wait, this isn't the, that's why. Nav. Let me see if I can find the PVT. There you go, nav PVT. So for example, when you look at nav PVT, which is like the core message that you're going to query the most, because it tells you your position, the time, and the velocity. So it's like, this is what you normally get from NMEA data. In this case, it packages it up into a binary format and spits it out to you over, you can use UART, you can use I2C, and there's a header, and then there's the data, which is 92 bytes. And then, here's how the data is structured. So you have the byte offset, and this means U4 unsigned 4-bit. X1 just means flags. U1 means byte. So it's 92 because 92 bytes and maybe looks like 20-ish different flags. Each, and then some of them are signed. So this is I4, so this is like integer 4. Some are unsigned, some are signed. Instead of me like doing like, okay, shift, add, like, is it little endian? Okay, now like set the bit. All we do is in the library itself, let me see if I can open the type def. Let's see if I can find PDT. Okay, so the PBT structure, you see it took that U4, I1, I4 here, U8, whatever, all these things, and made it into a struct, which doesn't really, it doesn't require any parsing, because you take that 92 bytes, you mem copy it onto a statically a heap or whatever stack, allocated uBlox nav PVTT type, and then you can just say, oh, what's the longitude, what's the latitude, and it pops right out. So what's cool is that means like you can basically have this library run on even the lightest 8-bit microcontrollers like an Atmega 8, because you would be able to do all of the functionality of, because there's like hundreds of messages and that would run out of memory, but you definitely could do quite a bit. And that's kind of cool. So yeah, and it was like, oh, it just has to be a little endian, has to be, you just have to have packed. And this is the kind of transcription work. So like going from this here, this table, to this is a nightmare. Okay? It's hell. It is actually like my toes are itching just thinking about me having to transcribe all of it. And then of course you also have to add the Doxygen comments.
But.
This would take, could I do it? Yes. But there's like no, I probably would have ended up writing some code that I would have like pasted this in, and it would have like done regular expressions and like tried to pop out a struct, and I would have QA'd it.
But let me ask you a question. Have you done stuff like this before?
Yes.
So you did you paid your dues, as they say.
Dude.
But here's a question that some people say.
I've died.
But
yeah.
What about the next generation of people? If you don't do it, even though you have, what are they gonna do? Are they gonna just like have it done for them, or are they gonna learn the hard way?
I don't know. But here's the thing: like, I know how to write MIPS and like Intel x86 assembly and AVR assembly, and I didn't really have to. But like, it's still, there was times in which it came in handy. I think also to Spark assembly. because I took that in school, like to, or while I was working on a project, I learned it. It's hilarious. One of the things I was thinking of is like, as like some of the better models were coming out, when I was in college, one of my summer projects, I think my freshman summer project, is I wanted to try to design a decompiler because I had taken a decompiler class. And I was like, oh man, I bet you could take binary code, turn it into assembly code, then find patterns and like decompile it, right? And like at the time, the Ghidra didn't exist. I got as far as the disassembly. That's where I learned x86 assembly. Is because I was like reading a lot of these like ELF files and stuff. And what's funny is like, I didn't get very far because it turns out it's like decompiling is actually an extremely hard project. But like now that's kind of the kind of thing that LM could like really chunk through very easily. But yeah, I don't know what people are going to do. But on the other hand, I don't see any benefit to this. Like there's benefit to knowing how structs work, but I don't see the benefit in transcribing structs.
Here's what I think from someone who hovers above you in orbit and watching this from the stratosphere down to the street. I think to be an expert, you're going to have to suffer, and you're going to do a bunch of stuff early on in your career or in school or whatever it is. And there's going to be friction, and that friction is what forces you to learn. No pain, no gain. Muscles hurt, brain hurts. And I think that's what's going to be the thing that a lot of people decide that, hey, I'm going to just learn some things as I become an expert. Because these tools in the hands of non-experts ain't so great. Maybe stick to the chat boxes, but you're in the terminal. You're already like 0.00001% of everyone anyways.
Yeah.
When you're in that terminal mode. That's just like a fact. So I think it's a little bit of a, what do they call it? Red herring or a straw man. I think it's a little bit disingenuous to say, oh yeah, people are just going to show up with their iPads and be able to do this. No, we're saying that there's new tools, and people like you that are experts are going to say, here's what I used to have to do. Here's what I do now. And on the way to become an expert, I guarantee you, if someone started MIT and went down your path, they're still going to learn a bunch of stuff that someone could say, oh, why am I even learning programming? Well, you're going to learn it the hard way no matter what. They're not, MIT's not going to say, just show up with your Claude bot. It's not going to happen. So there's going to be experts. So the answer...
No, you still have to build the compiler and compiler class. There's existing compilers.
The answer is, folks, you're not going to be able to skip ahead to this maybe ever. You're still going to have an expertise level of knowledge for making something else, make code like you through a terminal interface, through a bunch of Linuxy things like Ladyada does. So that's the answer. There is, if someone's gonna come along, not only do they have all the resources at Adafruit and you and all of us for now until we're gone, but they're gonna have the unending bit of resources that you've been releasing for free forever, which all these models are trained on. So the answer is, we've got plans, and our plans have plans now. So it's going to be okay, folks. No one's going to forget how to learn. Okay.
It's funny because it reminds me when I was at MIT, they had just transitioned, or while I was there, they transitioned 6004. No, was it not 6004? It wasn't 6011 either. Maybe 6111 or 6115. Digital lab, from using a nerd kit. Like you did build some circuits on the nerd kit, but the final was to like build a computer. And people used to build a computer, like the full ALU with TTL chips. But it's like, it sucks to build a full computer on a breadboard. It's like you have all this parasitic capacitance. You've got flaky rails. You've got wires that come loose. Like it sucks. And then I think they eventually moved at doing it all in VHDL. And, people were like, why'd you do this? Like, look, the point of this class is to teach people how computer architecture works, not how to sit there and suffer while you're wiring up like LS7404s.
So I think
time marches forward, guys.
Yeah, I do think that there's been a huge difference between how computers are taught over the years, and there's going to be another change. But the fundamentals of how some of these things work, you need to know your way around a terminal. You need to know your way around some of this terminology. You're never going to be able to vibe code what Ladyada is doing right now. It's a different thing when an expert says, I'm vibe coding, blah, blah, blah. Bad words to use. But, I'm watching ESR, DHS, HHA, the people with 3 initials that have something to do with software. Watching them, they're coming around. Cory Doctorow.
Some of these people
uses LLM.
We don't necessarily agree with all of their opinions, But they are well-known programmers.
Talking about things is not an endorsement.
Yes.
Everyone.
Guys, stop it.
Yeah. No, these people watching are cool.
Okay.
So anyways, we're confident that people are going to learn even more. But right now, it's a very hard thing to hear. I get it.
Yeah. Well, let me show you what didn't work great, because I think that's I think
yeah. Come on, Debbie Downer. What didn't work great?
So, it ran. So wait, what's one of these tests? And this is one test. So it's snowing outside, so I don't have my circuitry outside. It's pointing towards the window, so it does get like the date, and it got some of the latitude and longitude. And I asked it like, hey, just don't show like the exact location. And of course, it doesn't have a full fix, so some of this data is wrong. But what's interesting is like, I know this isn't correct. There must be at least one satellite, because when I run the satellite, like that comes in. So there might be something amiss with the parsing. And another thing is, as I look at this, it's like, I don't like numbsv. Like, what the hell is numbsv? Characters in a precompiled characters cost nothing. It should call it like num satellites, like num viewable satellites or something, right? It should not be numbsv. And ditto, like flags 01. I hate this. It should have a pound define, some macro for which flag is this, and also is it inverted, because sometimes you have to invert it. Ditto, like here, I really don't like this. It should do bit flags instead of having it do these weird shifts and ands. Lastly, for the latitude, even though in the datasheet, yes, it is multiplied by 1e -7, that casts it to a float. And now you're adding your float imprecision, because all like IEEE floats have imprecision. It shouldn't have done that. It actually listened to the datasheet, and the datasheet's like not wrong, but the datasheet led it the wrong way. What it should have done is split the latitude into degrees, and then like decimal, I don't remember what it's called, but like the decimal degrees of whatever they're called. And then it has like the rest of them, because it's like degrees, minutes, and then seconds, I think. And it's like 224. Anyways, like it's not terrible. It did at least getting the messages. They are like somewhat parsed. But it doesn't have the same pickiness I do about good names, like what's headmot or G speed. If it's ground speed, just have it called ground speed. Like why call it something else? Another question is, should the message parsing be like absorbed internally, and it stores all of these, like, should I have a wrapper that stores all these elements? You just query like, what's the current longitude and latitude, instead of saying like, hey, query it. I don't know. I guess I'm gonna have to figure out how people end up using this library. It also does do NMEA mode. So it'll be interesting to see, like, people just say like, look, I just want NMEA data instead. So is it perfect? Absolutely not. Is it ready to ship? No, not yet. However, I do like that it did all that transcription. It did do some tests. I want to do a sweep. What I like is, by having it do the test for each message, I can really see like, what does it think? What is it doing? Look at the output. It just saves me that time of writing my own test. I see the test, I read the test, and then I, tell OpenClaw, Opus 4.6, hey, fix this, this, and this. And then if it's something that I think applies to other messages, I'll say, go and apply it to the rest. So for example, where I might say like, hey, don't do, the valid flag should be turned into a bit field, because if you're going to access the time, if it's accessed as bits, it should be indicated as bits, because it costs nothing to have the struct to be more specific. And then I'd say, go and do the rest of the structs. So yeah, like, it will be nice. One thing that, would be interesting is like, drivers. So like, I write, Linux. I write like CircuitPython drivers as well for chips and devices. But there's people who write Linux drivers for a lot of these chips. And I notice that they don't always have like full thorough, like they do good drivers, but they could always be a little more thorough. be interesting to see if like people use LLMs and they actually end up getting, more documentation for the structs, more thorough message handling type stuff. Okay, so I think that's it. Oh, there's one more quick thing. So I'm just revising the PCB for this GPS unit. Oh, can we go to the overhead?
Yeah.
Oh, it froze up.
It did?
Oh, no, it's just very
What happened?
slow. It's just very slow.
Whoa, weird. I've not seen this before.
Well, anyways, this is the GPS unit.
I think it was actually asleep over there.
Oh, yeah, it could be. It was like, what are you doing? So this is the GPS unit. So you see, like, it's working and like the pulse per second is ticking off. Okay, you can go to the main computer again. I wanted to make it so you could disable the LEDs, but my standard package for solder jumpers was kind of big and it didn't fit. And I was like, well, I don't think a lot of people are going to cut the LED, but I figured like, it should be, why not make it? So I was like, oh, I should make one that's like half the size. I mean, 70% smaller in each direction. And for that, I did ask Claude to do it. I just said, hey, please make a smaller footprint. Find this one and then make it 70% smaller in each direction. And it added the footprint and then added the device and then added it to the existing solder jumper. And like, it actually did a good job. Like, I talked earlier about having it do more complex footprints. This one is like not from a data sheet. Like I didn't feed a data sheet and tell it to copy it. I said, take an existing footprint and modify it, and did a good job. So I think like, I'm starting to like practice more with like, okay, let's see if we can get Claude Code to do more footprint designs. Okay, cool. All right, well, let's
pause here.
And we're going to get into the great search next.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey Data Fruit. Thank you so much, DigiKey. This is the time of the week where Ladyada helps you, yes, you, find the things you want on digikey.com. Ladyada, what are you looking for this week?
Okay, thank you for asking. All right, let's go to my computer or to DigiKey. So we're back. Thanks everybody for holding tight and being able to find parts, hopefully, on DigiKey while we were on maternity leave. So I've been playing around a lot with the SAM M8Q. I started this board last year and then got snowed in, both now physically and literally, and mentally by the 475-page message data sheet, which is this one, a massive data sheet with thousands of different segmented message elements that need to be hand parsed. Thanks to the use of LLMs, I've managed to get that distilled down to a more reasonable job. And so getting this board out, and this chip is still available. You can still buy it. But it is an R&D. It's not recommended anymore by DigiKey, by uBlox when I looked it up. And that's okay. I get it. Like, we'll still stock it because people sometimes search for, here, I'll go to the page. Now, let me see if I can find it. What's interesting is that like the uBlox page they have like the file, but the actual page, here it is. It's called the Max 8. So they say, use the new M10. And about a year ago, we did do a great search where we found and talked about the M10, which is actually pin compatible. So you can drop it in, and I probably will, I'll just do that as well. But since then, things have gotten even better. So last time we searched for, uBlox modules that had antennas. So if we go back here to RF receivers, and I want to look for blocks, dash blocks, and active, and normally stocking. Gives you about 50 different modules, which makes sense. They have a couple of varieties. And you'll see, the M10 is like very popular. If you don't need an antenna, it's actually very affordable too. It's only like $6 or so. The version with the antenna is about $12, $13, a really good deal. And then I noticed that they also had the DAN, which is only like $2, $3 more expensive than the SAM M10Q. And I was like, well, what's the deal with this? This also has, this is new. They didn't have this version last time we looked. This is a new chip. And when you look on the uBlox page about the DAN, this is the DAN F10. This is a chip that has L1 and also L5. And you're like, what are you talking about? So basically, when you have a GPS module, it's receiving messages using the 1.575 gigahertz frequency from all the constellation antennas, satellites. And they're beaming data and they're like circling the globe. And there's GPS, which is the American Global Navigation System. There's Beidou, the Chinese one, Galileo, the European one, and then GLONASS, which is the Russian one. And all these use L1. And I think GLONASS is, I don't know if that one's online yet, but the Beidou and Galileo, I think, are. And they transmit over L1. And like this frequency, when it was designed, like it was state of the art, and it works pretty damn well. I mean, of course, it was designed initially for, military and industrial uses, but now we use it a lot for commercial, just plain navigation, knowing where you are, how to drive someplace, directions, maps, etc. It's incredibly useful because it's great. It's free. You just point the antenna at the sky, get data. It tells you exactly where you are. But the thing is, it doesn't tell you exactly where you are. It tells you right within 2 to 3 meters, like about 10 feet, is the accuracy you get. And also when you are in what's called like an urban canyon where there's all these tall buildings, the messages bounce between the buildings. And so you get this thing called multipath reports where the timing of the data you get multiple readings and some of them are bouncing off in different directions. And it gets much, much harder to know where you are. And that's why, especially if you have older GPS units and you are in New York City or like maybe like Toronto or I don't know, Miami or something, someplace with very tall buildings, you're going to see, sometimes you jump around a lot. Like even if you're standing still, it won't know quite where you are. It'll show you a couple, maybe even a couple blocks off of where you're located because it's measuring that multipath, the multipath signal. Now, some GPSs now have, they reject multipath and they have more filtering, so they've gotten much better. But with the addition of L5, which is the new band, and now I'm not going to remember the band number, so let me look.
Is it a new band with a new satellite, or is it a new band with some other means?
I believe that, look, I think they had to replace all the satellites.
Yeah.
And the data is sent now.
I should look this up because I actually don't know.
Yeah, I looked it up like very, briefly because I was like, what is this?
Is it like a new satellite they put up? Is it a one that had got retrofitted? Probably not. Is it a bunch of little ones? Who knows?
Well, I don't know. Look, the satellites fall out eventually, or they stop working. We have to constantly replace them. So we've been replacing them and we're replacing them with L5 as well, which gets, it has 1.17-ish gigahertz in addition to the 157 gigahertz. And even though this is a lower frequency, it's a wider band. And so it can transmit more information. It's also less susceptible to the multipath issues. And so according to uBlox, and I will absolutely test this because we're in the Manhattan, baby. We can go to Manhattan very easily, and we'll do some tests. When you combine both L1 and L5, you can get 1 meter precision, 1 to 1.5. So about twice as good, which is a big deal given that you don't have to invoke RTK price, like level pricing. It's only a couple bucks more. And of course, as everyone starts getting into like now that Galileo and Beidou and GPS is apparently, they're transmitting the data, but they don't promise that the data is good, but it's still apparently quite good. So you can use it. You just have to turn on a bit to tell the module, hey, enable the GPS. In fact, if you look at, it's kind of funny. It's going to be online, in a couple months. So late 2026. Yeah. So as they say, hey, if you're using the GPS satellite, not Galileo or Beidou, just you have to turn on please listen to GPS by default. I think once they start sending healthy data, it'll start using them. So this is kind of neat because it's not pin compatible, but I really dig that it has the antenna built in, and the price is really good. And it's going to be a really good way for people to get involved in L1 and L5. You know, if we're stocking L1/L5 dual modules, if they don't have an antenna, you can actually see there's like a dual antenna here. There's like one antenna, and then there's a little like antenna underneath. The little mini antenna hat on top of the antenna building. We'll have to stock passive and active antennas that do L1, L5. So that's probably something we'll have to do. Because while, you know, some people like the antenna built in, most people actually will also want a version that has a UFL, and then you connect to an external antenna, and the antenna, you know, you can put wherever you want to get the best signal. So yeah, this is the Great Search product. I might also cover it on NPI. Maybe I'll get some of these and try them out. The Dan F10N is another great uBlox chip antenna already on, ready to go, and it supports both L1 and L5, so you get better accuracy / precision all over the world, and especially in cities.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
I'm sad to say we must be on our way. So by Spirit Whiskey is going far away.
Far away.
To the other side of the room. Okay, so we'll see
Okay.
everybody next week.
Stay warm.
Stay warm. We'll see you during the week
Yes.
in this format and more.
You're gonna see more and more videos from me as
We've been
the baby gets
we got a lot.
older.
We got a lot.
Yeah, but we're doing
Okay.
a lot of content,
We got a lot of content.
a lot of
Okay,
hardware.
like and subscribe. We never say that.
I never say that.
Okay.
But if you have a Great Search request, send them over.
Yep. Okay.
I do have
everybody.
a request for the ICS 43434, which I'll do next week.
Okay.
Okay, cool.
Bye bye.